Hello and welcome to this video on rotations. So in this video we're going to be looking at how to rotate shapes using a given angle and a center of rotation. Then we're going to look at how you would go about describing a rotation that's taking place. Okay, so we've got an example here, so we can see we've got a rotation that's happened here. So we've got the purple L shape here that's been rotated onto the green L shape. So some things to look out for, to consider with rotations. Rotations turn a shape around a fixed point, and this is called a center of rotation. And you need 3 pieces of information to rotate the shape. So you need that center of rotation. So that will either be given to you with a mark on a diagram, or you might be given a coordinate. You need the angle of rotation. So typically this would be 90, 180 or 270. They don't really vary too much from those on exam questions usually. And then you need a direction of rotation. So whether this is clockwise or anti-clockwise. So you will only be given this if it's not 180 degrees. They will not express this if the rotation is 180 degrees, because you could go either way. Okay, so if you are asked to describe a rotation, you need to include the following things: the center, as I've already said, the angle of rotation, and the direction of rotation. So you need all 3 of those things. Once again, you don't include the direction if it's 180 degrees. And this angle, this example here, so this rectangle ABCD has been rotated 180 degrees about the origin. So the origin is a word that's used for the coordinate 0, 0. So you can say 0, 0 as well, but the origin is also acceptable. All right, let's have a look at some examples of rotations then. Okay, let's have a look at this particular example here then. So I've got a piece of tracing paper. You might be able to see that to help do this question. So you are allowed these in the exam. So let's have a look at the question first before we have a go. So it's asking me to rotate triangle A 90 degrees clockwise about 4, 3. So that is our center of rotation there. So it's always a good idea to mark that on there. Then we need to get our tracing paper. Now, what I would always advise you to do is I would advise you to draw a little arrow pointing north on your tracing paper, because this is essentially 0 degrees then. So you know that you're going to at least get your angle correct if you can follow that, because when you go like that, that's 90 degrees, and then south is 180, and then west is 270 degrees. But always start by facing north, I would say. And then mark on your center of rotation just here. Mark that on your actual tracing paper. And then you need to start the process of tracing your triangle. So we've got it there. Now it's a case of moving it 90 degrees. So we're not quite there yet. And it's about there, I think. Sorry, my arrow's gone off the page. I'll just move it up a little bit. There we go. So we should now see we've rotated it 90 degrees because your arrow is pointing east. Then all you've got to do is just mark your points on your actual piece of paper. So just take your time with this. And then join them together. And if you want to check that this is right, what you should be able to see is that if we take a look at, let's say, if we start again, look. If we take a look at this point here, it's the same distance from the center of rotation as here. So this is the exact same point here. So if I mark that on there, I do a little cross on there, and when we move it here, it's the same distance away from the center of rotation. Okay, and that will always be the case because it's being rotated about that point. Okay, so in this one then we're being asked to rotate the shape 180 degrees about 0. So it's essentially the origin here. So we've got that there. So as you can see, I've already drawn my arrow facing north on the top right hand side of my tracing paper. Now I'm going to trace this shape. So there we go. Now we're going to have to rotate it. So if we go down here, well, we're only at 90 degrees there. So as you can see from the arrow just down there. So we've got to keep going. And then you will see now we're at 180 degrees. So we should be just here. So let's mark this on. Just there. So let's draw it all in. So if we take a look then at maybe this point on the shape there, that's the closest one to the center of rotation. It's 2 diagonal squares away here. Same point, it's also 2 diagonal squares away here. So that's how we know if we have been successful with our rotation. It should still be the same distance from our center of rotation. Okay, so now we're going to move on to describing rotations. Okay, so now we're going to have a look at how we would go about describing a transformation. So this question is asking us to describe fully the single transformation that maps triangle A onto triangle B. So as you can see, I've already traced the triangle here. I've done my little arrow pointing north. So now I've just got to move it. Now, we don't know the center of rotation at this point, so we can just move it around. So we can see that it's 90 degrees anti-clockwise. Okay, so we would write down on our answer line, rotation, 90 degrees anti-clockwise. Now you could also do this as 270 degrees clockwise if you want to, because if you go around there, there's your 90 degrees clockwise, there's your 180, and there's your 270. So you could do it that way, doesn't really matter though, but we're just going to do 90 degrees clockwise for this one. Then the trickier bit is to work out the center of rotation. So if we have a look at what I've done here, I did do a little cross on this point here on the shape, which is the same as this point here. So then we need to try and find a coordinate that's the same distance from both of those. Well, the one they use quite often is 0, 0. We can see it's not that though, because that's only got 3 squares in between there. It's got 8 there, so we know it can't be. We know it can't be that one. So let's move across a little bit. And if we go here, we'll see that we've got a little block of 6 squares there between those 2 points, and the same here. So our center is going to be 1, 0. All right. So this is always the tricky bit. It's about just trying to find a coordinate that's the same distance from the same vertex on the shape. Okay, our final description question then here is asking you to describe the transformation that maps triangle P onto triangle Q. So I've already done a little arrow pointing north there, and I've sketched out my triangle. So let's move it around. Not my triangle, trapezium, sorry. So we've got 90 degrees there. So we know it's not 90 degrees. So if we keep it moving, we can then see it's 180 degrees. So by writing rotation 180 degrees, we've already got a mark in the bag. Now the tricky bit is to work out the center of rotation. So if we mark a little point on there, and mark one of the corners, so we'll use that one, then we can go down here. Well, we can clearly see it's not 0, 0, which it quite often is. So let's sort of move around this area here somewhere. Well, 1, 1, it can't be 1, 1. Can't be 0, can't be 1, 0. But if we go to 0, 1, this point here is exactly the same distance from trapezium P as trapezium Q. So we've got exactly the same distance between them there. So our center would be 0, 1 on this particular one. Okay, and that's it for this video. So please hit subscribe, and there'll be loads more videos coming your way over the next few months. Thanks very much. Bye bye.